Welcome guys. In this video, I will be solving this particular question from the chapter name Ray Optics of Physics. Okay, the question says that a ray of light enters an arrangement of prisms at grazing angle of incidence as shown in the figure. Okay, the arrangement contains 5 isosceles right angle triangle prisms having refractive indices mu1, mu2, mu3 and mu4, mu5. Okay, if the ray emerges out at a grazing angle, then the refractive indices of the prism must satisfy which of the following equations. Okay, now here the grazing angle means the angle must be 90 degree. Okay, according to the given question, the angle of incidence at this prism mu1 is 90 degree and the angle of refraction for this mu5 prism is also 90 degree. If these conditions are followed, then what would be the equation that must satisfy all these conditions? Okay, in terms of refractive indices. Okay, let's dive into the question now. Okay, now I'm going to apply Snell's law for all the planar surface, all these surfaces. Okay, let's say this is 1, this is 2, this is 3, this is 4, this is 5 and this is 6. Okay, now this is 90 degree. I'm taking refractive index of air as 1 to make the calculations easier and faster. Now mu a into sine of 90 degree. Now I'm going to apply Snell's law for surface 1 equal to, okay, now this is r1 mu1 r1. Okay, mu1 into sine of r1. In this question we will be using another concept, that is complementary angles. I'm going to extend this line. Now if this is r1, then what will be this angle? Since this is a right angled isosceles triangle, this will be the complementary of the angle r1. So it will be 90 minus r1 if I take this as 90 degree and this is also 90 degree. Okay, you will be getting it. Now for this planar surface, if this is an incident angle, let I take r2 as a refracted angle. If this is r2, then what will be this angle? This will be 90 minus r2 and so on. This is a core concept behind this question. Now let's separate. So there are 6 planar surfaces, so there will be 6 equations. Now for planar surface 2, angle of incidence, now mu1, which is this prism, and sine of 90 minus r1, as this is the angle of incidence for this planar surface, equal to mu2 into sine of r2, as this is the refracted angle for this surface. Okay, since we know that a fundamental formula in trigonometric function, sine of 90 minus theta equal to cos theta, now mu1 into cos of r1 is equal to mu2 into sine of r2. Let's say this is equation 2. Now let's apply Snell's law for planar surface 3. Okay, now what is the incident angle for this planar surface? Mu2 into sine of 90 minus r2 equal to mu3 into sine of r3. So mu2 into cos of r2 equal to mu3 into sine of r3. Let's take this as an equation 3. Okay, now you will be noticing the repeating pattern of these equations. Let's apply for 4, planar surface 4, mu3 into cos of r3 is equal to mu4 into sine of r4, and then mu4 into cos of r4 is equal to mu5 into sine of r5, mu5 into sine of r5 is equal to 1, because this particular equation, this planar surface, now the light ray finally enters the air medium back and the refractive angle is again 90 degree. So 1 into 1 into sine 90 degree equal to 1. So therefore this is equation 6 and this is equation 5 and this is equation 4. Okay, now let's take equation 1, let's square it. Okay, so mu1 sine of r1 whole square equal to 1. Okay, now I don't want sine of r1. I need equation in terms of mu1 square, mu2 square, mu3 square, and so on. Okay, now to get rid of sine r1, I'm going to add equation 2 by squaring it. Okay, so mu1 square into sine of r1 square plus mu1 square into cos of r1 square equal to 1 plus mu2 sine of r2 whole square. We all know that sine square theta plus cos square theta equal to 1. Let's use the same formula here. So mu1 square into sine of r1 square plus cos of r1 square equal to 1 plus mu2 into sine of r2 whole square. Okay, now mu1 square equal to 1 plus mu2 sine of r2 whole square. Okay, now I need to get rid of sine of r2 square. So to get rid of sine of r2 square, I'm going to square and add equation 3, but this time cos of r2 at the left side. So I'm going to flip this equation and add it. Okay, so by turning this equation to the left hand side, I will be getting mu1 square plus mu3 sine r3 whole square equal to 1 plus mu2 sine r2 whole square plus mu2 cos r2 whole square. So I will be getting mu1 square plus mu3 sine of r3 whole square equal to 1 plus mu2 square. Okay, now I need to get rid of sine of r3 square. Therefore, I'm going to add equation 4 by squaring it. Mu1 square plus mu3 sine of r3 whole square plus mu3 cos of r3 whole square equal to 1 plus mu2 square plus mu4 sine of r4 the whole square. Now we will get rid of this, and mu1 square plus mu3 square equal to 1 plus mu2 whole square plus mu4 sine of r4 whole square. Now to get rid of sine of r4, I am going to add equation 5, but this time I will be getting cos of r4 in the left side. So to get rid of this sine of r4 term, I am going to flip that fifth equation and I will be squaring it and adding it. So mu1 square plus mu3 square plus mu5 sine of r5 the whole square equal to 1 plus mu2 square plus mu4 sine of r4 whole square plus mu4 cos of r4 whole square. So we will be getting mu1 square plus mu3 square plus mu5 sine of r5 the whole square equal to 1 plus mu2 whole square plus mu4 the whole square. Now to get rid of this term sine of r5, I am going to add the sixth equation by squaring it, mu3 whole square, because already cos of r5 is on the left side, so we no need to flip that equation. So mu5 whole square, I am writing directly, equal to 1 plus mu2 whole square plus mu4 whole square. Now mu1 square plus mu3 square plus mu5 square equal to 2 plus mu2 square plus mu4 the whole square, and this is the final answer. See, look at the beauty of this question. Everything is the basics. This we have used is Snell's law and trigonometry, two equations. That's in the option C is the final answer. If you might have liked this video, like, share and subscribe. Thank you.